Hi there, and welcome to Tech Tips Tuesday. One of the key things in a speedy troubleshooting procedure is being able to read resistor color codes very quickly. And in this episode, I'm going to show you how to do just that. So let's get started. The first thing to do, if you haven't done this already, is memorize this color code chart. This color code chart is pretty much standard for most all electronic components, which means that it's not only valid for resistor color codes, it's also valid for capacitors and inductors as well. You'll also notice that rainbow-colored ribbon wire will also follow this coding system. So it's very important to memorize this color code system, so definitely do take the time to do that. You can find this system online if you just type in resistor color code chart under images or resistor color code table under images. You'll get this in all sorts of different shapes and sizes. And what I want you to do is I just want you to memorize the color and the number. I don't want you to go into the multipliers or anything like that, because what I'm going to show you in this video is a shortcut that's going to make working out the values of these resistors quite a bit easier. So the first resistor that we're going to look at here is this one right here. So this resistor here has red, violet, red, and gold on it. So whenever you're working out the values on a resistor like this, you always work towards the tolerance band, and the tolerance band on this one is gold. So how you tell the tolerance band on most resistors, most standard resistors, it's either going to be gold or silver. Sometimes it will be red, and they will space that red band quite a ways away from the rest of the band so you don't get confused at which end to start. So we're going to work this way towards the tolerance band, and we'll work out this value here, and I'll show you the shortcut. So I'll just grab a piece of paper here and a pen. So that resistor that we just looked at was red, violet, red, and gold. Okay, so if we look at the color codes for this, we see red is 2. All right, so I'll write 2 here. Violet is 7. Red we know is 2. And gold is 5%. So that just means that when you work out the value of this resistor, if you were to measure it, it should be within 5% of what this works out to be. That's all that this is. All right, so now this is the first significant figure, this is the second significant figure, and this is the multiplier right here. So the quicker and easier way to work this out is you just keep these two the same. So we have 2, 7, and the multiplier we know is red, which is 2. So what we do is we convert that number 2 into 2 zeros. Okay? So if this was a number 3, it would equal 3 zeros. All right, if it was a number 3, this would be orange, but it's red, so it's number 2. So we just take those 2 zeros, put them here, and we have 2700 ohms at 5%, and that's just how easy that is. So I'll grab another piece of paper here, and we'll take a look at another resistor, and I'll give you another example. I'll put the paper here. All right. So here's another resistor. We have the gold band at this end, so we know that we have to work this way. So we've got brown, black, and yellow, and then we have the gold band there. So brown, black, and yellow. All right. So we have brown, black, yellow, and gold. So if we look at the chart here, we see that brown is 1, We see that black is 0. We see that yellow is 4. And we know that gold from the last time is 5%. So what we do is we keep these the same. All right, so we have 1 and 0. Okay. And we have a 4 on this one here, which is our multiplier. So we turn that into 4 zeros. So we have 1 0, 1, 2, 3, 4. 100,000 ohms, or 100K for short, at 5%. And that's really just how simple it is. So we can do one more here. This is an old carbon composition resistor here. And the color coding system on this one is blue, gray, brown, and silver. Okay, so we have blue, gray, brown, and silver. So we know that blue is 6. Okay, we know gray is 8. We know brown is 1, and silver is 10%. So that means that this resistor will be within 10% of what its rating is if we were to measure it. So again, we leave the first and the second significant figure the same. So we have 6, 8, and this is 1, so that would equal 1, 0. So 680 ohms. And that's, again, just how simple it is. So in order to work out low-value resistors, so the multiplier band being either gold or silver, what we're going to do is we're going to look at this a little bit different again. So we're going to look at gold being the multiplier band as over 1 ohm, and silver as being under 1 ohm. All right, so if I take this resistor here, this resistor is yellow, violet, gold, gold. So gold is the multiplier band on here. So if we remember that gold is above 1 ohm, that makes working out these resistors really quite simple. So gold would be really from 1 ohm to just under 10 ohms is where gold would go. All right. And then of course the last gold band is being the tolerance band there again. All right, so grab a piece of paper here. So if we have this last one was gold, this one was gold, and remember this was yellow and violet. So yellow is 4, violet is 7, gold is above 1 ohm. All right, and this is, again, 5%. So we have this, if this is above 1 ohm, we have 4.7 ohms. So remember that this is above 1 ohm and it will only go to just below 10. So we have 4.7 ohms because this is gold. All right. If this was silver, it would be below 1 ohm. So I have another resistor here, another carbon composition resistor. And this one is red, violet, silver, silver. Okay. So, grab another piece of paper here. So this is silver, and we had red and violet. So this is below 1 ohm now. So red is 2, right? Violet is 7. And this is below 1 ohm. So we put a decimal place there and we get 0.27 of an ohm. And that's how simple it is to work these out using this shortcut. Today's bonus tip, reading domino style mica capacitors. So all these capacitors read in picofarad, and in order to read these correctly, you have to read in the direction of the writing. So we start at this end and work this way. This one here has a little arrow on it, which shows us the direction to read this capacitor. So the first dot stands for either EIA or military. So if this was a white dot, it would mean that this capacitor is EIA or Electronic Industries Alliance. But since this is a black dot, that means that this is military. This is the first significant figure, this is the second significant figure, and this here is the multiplier. So we have 2, 0, and if we remember in our resistor color codes, the multiplier is 2, so we have 2 zeros here. So we have 2, 0, 0, 0. 2000 picofarad or 0.002 microfarad. This here dot is the tolerance of this capacitor, and this dot here is the characteristic of this capacitor. Now, the characteristic for all these capacitors is quite a bit different. You need to look at the manufacturer's data sheet. So this will entail like production line requirements. It'll like temperature coefficients and things like that, maybe even Q of this capacitor. So you need to really look at it, and it's really different for most all manufacturers. So like if this was a Sangamo or a mica mold or anything like that, these would all mean different things. So the most important thing to know on these capacitors is these 3 digits right here. This gives you the value. So we look at the second one here, we know that this is black, so that's military again. So this is orange, white, red, so we have 3, 9, and 0, 0 again, so 3900 picofarad or 0.0039 microfarad. Gold again for tolerance, and brown again for the characteristic dot. This is the same manufacturer as well as this one here. Now you can see on this one here, they've only put 3 dots on this capacitor. So this one's relatively easy to read. We have green, black, red, so 5000, so 5000 picofarad or 0.005 microfarad, however you want to look at that. On this one here, this is a smaller capacitor, and we can see the arrow is pointing this way. Black for military. This is violet, so 7. This is green, 5. And we know that brown is 1, so 751. So if we take that 1, that equals 10. So 750 picofarad. We have silver as our tolerance, and again we have brown as the characteristic dot on this capacitor. And that's how you read domino-style mica capacitors. Well, here we are at the end of another Tech Tips Tuesday. If you found this color code video useful, you can let me know by giving me a big thumbs up, and hang around. There'll be many more topics just like this in the very near future. So until that time, bye for now.